So let us move on to the next question. So now the question, because root x is there, cos you cannot take it as t. The only possibility that you have is you have to put the value of root of x to be t. So if you're taking root of x to be t, another root x has to come in the differentiation. Let us try to see whether we'll get it or not. Differentiate. And derivative of root, it is better you remember this derivative of root, d by dx of root x. D by dx of root x will be nothing but 1 by 2 root x. That's the formula we have. You remember this one? D by dx of root x to be 1 by 2 root x. So now let us try to apply that one here. Differentiation of root of x will be 1 by 2 root of x into derivative of x will be dx is equals to dt. But if we try to observe, this root x is in the denominator 1 by root x. So only retain 1 by root x, send that 2 on the other side. So we'll be getting 1 by root x into dx is equals to cross multiply with the 2, so 2 times of dt. Now just try to plug in this value back there in the given integral. I is equals to, so integral of what you are having there in the numerator, it is cos of root x. So cos of root x is taken as t, and 1 by x dx will be 2 times of dt. This value which is there, 1 by root x. So if nothing is there, you can take 1 by, right? 1 by root x into dx. This value will give us what value? 2 times of dt, this one. But however 2 is constant there, you can take the 2 outside and write cos of t into dt. 2 as it is, we know the integral of cos of x into dx is nothing but sine of x plus the constant of integration c. Therefore, we'll be getting sine of t here in this case plus the constant c. But what is the value of t that we have taken? T value is root x. Therefore, we'll be getting 2 times of sine x value is root x plus the constant of integration c. So therefore, that will be the required solution.